Now example 5.9. Actually in text it is given to you the car taken in example 5.8. If it is moving on the road having coefficient of friction mu to be 0.5, then calculate the maximum compression of the spring. But we take entire question here, okay, and then we make some change in it. To simulate car accidents, auto manufacturers study the collision of moving car with mounted springs of different spring constants. Consider a typical simulation with a car of mass 1000 kg moving with a speed 18 km per hour on a smooth road. Now we will not consider the road that is a smooth one. Simply we will consider it is moving on a road and colliding with a horizontally mounted spring of spring constant 6.25 into 10 raised to 3 Newton per meter. Now when we consider road is not smooth, means coefficient of friction that is given to you. So taking the coefficient of friction mu to be 0.5, calculate the maximum compression of the spring. Now we can solve this problem with the help of work energy theorem. We know this thing, the change in kinetic energy, that is the total work done, as well as the total work done, that is equal to the net force into displacement. Okay, so here first we list out the quantities given to you. Mass 1000 kg, speed 18 km per hour, that is 5 meter per second, spring constant K, that is 6.25 into 10 raised to 3 Newton per meter, G, that is 10 meter per second square. Now see the situation. Car is moving towards the spring. So the frictional force that is in the opposite direction of the motion and the spring force that is also in the opposite direction. Clear? So here first we calculate the change in kinetic energy when maximum compression takes place. So when maximum compression takes place, final kinetic energy will be 0. Initial, that is half mv square, and that is equal to W. So we can write now the work done by the net force. So one force, that is the spring force, which is in the opposite direction of the displacement, as well as second force, that is the frictional force. Now spring force, that is the variable force, and work done under the effect of variable force that we calculated in case of spring, and that is equal to half k xm square, where xm, that is its maximum compression. Now for xm displacement, the work done by the frictional force, that is frictional force into xm. So these both are in the opposite direction of the displacement, so negative sign is there. Now frictional force, that is mu into normal reaction, that is mg. So W, that is minus half k xm square minus mu mg xm. Compare these two equations. So we can write half mv square equal to half k xm square plus mu mg xm. Now here multiply both the side by 2. So we can write mv square and take it on right hand side. So kxm square plus mu mg xm minus mv square, that is equal to 0. Substitute the values. 6.25 into 10 raised to 3 into xm square plus 2 into 0.5 into 10 raised to 3 into g, that is 10 into xm minus mass 1000, that is 10 raised to 3, v, that is 5 square, equal to 0. So you will get, see, this 10 raised to 3, take common, take it on right hand side, will be cancelled. So 6.25 xm square plus 10 xm minus 25 equal to 0. So divide this equation by 1.25. So you will get simple quadratic equation 5xm square plus 8xm minus 20 equal to 0. Now find out the roots of this one by your usual method. So that is minus b plus under root b square minus 4ac upon 2a. And if you solve this one, you will get xm that is equal to 1.35 meter. It implies that in this particular case, the maximum compression of the spring that will be equal to 1.35 meter. Clear?